Okay everybody, it's the 10-minute tutor today, and we're back with another video today on kinematics and physics. So if you guys watched our previous video on the basics of kinematics, you would know that this video is supposed to be an extension of that. So we're going to talk a little bit more about the equations in this video and how to solve kinematics problems. But if you guys want to know the basics of kinematics, such as drawing a free body diagram and what free fall means and all of that, be sure to check out our previous video titled How to Draw a Free Body Diagram / Kinematics Basics. So there's four main kinematics equations that you're going to use in one way or another to solve most kinematics problems. And before I list the equations, I want to list the variables that are part of the equations. So you're going to have D, which stands for displacement, which I have made a video on displacement, and simply displacement is the difference between your final and your starting position. Then you have VI, which stands for initial velocity. And then you're going to have VF, which is your final velocity. Your T, which is your time, but it's really your time for which the object moved, so time of motion. And then A for acceleration. So I've made previous videos on all of these topics, such as what velocity means, what is initial, what is final velocity. So if you guys are confused on what any of these means, just be sure to check out our previous videos in the physics playlist. But for now, all of these variables you see here are going to be part of the four main equations in kinematics that we're going to be talking about. So the first main equation is D equals VIT plus 1/2 AT squared. So it's displacement equals initial velocity times time plus 1/2 of acceleration times time squared. The other equation is VF squared, so final velocity squared, is going to be equal to VI squared plus 2AD. The third equation is going to be VF equals VI plus AT. And your fourth equation is going to be D equals VI plus VF divided by 2 times time. So when you're given a kinematics problem, depending on the types of information that you're given, you're going to decide which equation to use. So for example, if you're given the initial, final velocity and your time, you're going to use equation 4 because you have all the variables to solve it. But if you're not given all those variables, for equation 1, you can't do that because you don't have the acceleration for that type of problem. So you need to determine which equation to use based off what you're given. Okay, so now that we know the four main kinematics equations that you're going to use for most of the problems, along with the variables associated with them, it's time to solve some problems with these equations. So there's a simple problem-solving strategy that I use that's only 3 parts, and it makes it a lot easier to solve the problems. So the first part is to list what's given. So you want to list your given variables. So for example, say you're reading through something and it says the initial velocity is so-and-so, the final velocity is something else, and then they give you the acceleration. You want to make sure that you write down that you have each of those values. The second part would be to look through your equations to use for given variables. So now you want to look for the proper equation. So based off the given variables that you want to you want to look for an equation that you can substitute those variables in and find your unknown, which leads us to the last part as being substitute values, right? So that'll be the last part in terms of the problem-solving strategy. Now to put this into use, we're going to go over a couple problems here. So the first one is your friend is driving when the light suddenly turns yellow. Your friend was initially moving with a velocity of 30 meters per second. Your friend slams on the brakes, comes to a stop, and the acceleration was -8 meters per second squared. Determine the displacement of the car. So we said that your friend was initially moving at 30 meters per second. So that means your VI was 30 meters per second. So that's given. And then we said your friend slams the brakes and comes to a stop. So that means their final velocity must have been 0 meters per second. Whenever you see somebody coming to a stop, guys, just remember that that means your final velocity was 0 meters per second. And the acceleration was also given at negative 8 meters per second squared. Now the negative sign just indicates direction, since acceleration is a vector quantity. If you're confused about vectors, make sure to check out our video on vectors in the physics playlist. So now we want to find D. So you want to find displacement. So the displacement of the car from when you slam the brakes to how far it took to stop. So now that we have the initial, the final, and acceleration, if you look through the equations, the best equation to use would be Vf squared equals Vi squared plus 2AD. So this would be the best equation to use for this example, since we have the initial velocity, we have the final velocity, and we have the acceleration. We're just looking for the displacement, which can easily be done by substituting. So substituting the values into the equation, you have 0 meters per second squared for the final velocity equals 30 meters per second squared plus 2 negative 8 meters per second squared plus 2a, and then there's a d over here. So when you solve for the d, you're going to get a value of 56.3 meters. So this is the displacement of the car from when you slammed on the brakes to when it stopped, was 56.3 meters. So the car skid that distance. Okay, so we're going to do another problem here. So a person is on a motorcycle waiting on the side of the street, and they decide to floor it, accelerating from rest to a rate of 6 meters per second squared for 6 seconds. What is the displacement of the motorcycle? So we know we have our time as 6 seconds. We have our acceleration because they accelerated at 6 meters per second squared. They did it from rest, so that means the initial velocity was 0 meters per second. And we want the displacement. So we have all these variables, but we want the displacement. So determining the equation to use is pretty simple. Once you look through all the equations, you will be able to determine that you would want to use the equation of D equals VIT plus 1/2 AT squared. In this example, since the initial velocity was 0, it cancels out the time, so you don't need to include the first part of this equation, which you would see in some examples. So D equals 1/2 AT squared would come out to 1/2. We have the acceleration of 6 meters per second squared, 1/2 AT, and then 6 seconds. So that means the displacement of the motorcycle from stop is going to be 108.0 meters. So it traveled 108 meters. So now to do a free fall example pretty quickly, you throw a ball vertically upwards with an initial velocity of 30 meters per second. So the initial velocity is 30 meters per second, right? And determine the height to which the ball will rise above its initial height. So we want the height. So that is actually the displacement. So they may be confused here and be like, well, we only have the initial velocity and they want the displacement. How could we possibly solve this? Well, if you watched the previous video on the basics of kinematics and free fall body diagrams, you would know that in a free fall situation, your VF is actually going to be 0 meters per second because it comes to a stop when the ball gets to the top of a vertical trajectory. And the acceleration is going to be negative 9.8 meters per second squared. The reason it's negative is because the acceleration is bringing the object downwards. The negative sign for the acceleration is just directional. So you just have to know that VF equals 0 meters per second and A is negative 9.8. And now we have all of our variables to solve the problem. So we want to use the equation of, if you're looking through the equations, you would see that you would use VF squared equals VI squared plus 2AD. So now, when you solve this equation, we know VF squared is 0 meters per second, so 0 meters per second squared equals VI squared plus 2 negative 9.8 meters per second, 2A, and then D is going to be part of the second equation. So now that you have these variables, you're going to solve for your D, just algebraically, and you're going to get 45.9 meters. So that means that the ball will travel upwards 45.9 meters before reaching the peak. So when the ball goes up and up and up, this displacement here, the ball goes up and up and up and up. This is actually, right here, is 45.9 meters. So we're going to be making videos every single week on different subjects such as physics, chemistry, biology, and mathematics. So be sure to like and subscribe.